All right, we're on our last page of the review. We've got Tana's going to have a birthday party for her niece. She's planning to have large cookies. The bakery sells two sides of cookies. One has a diameter of 24, so remember diameter means all the way through the center of the circle, and another has a diameter of 8. So all the way through the center of the circle, and that's 8. How many 8-inch cookies would be equivalent to two 24-inch cookies? So we need to compare their areas. So if I need to do area, on our reference sheet, our area formula is pi r squared. R is needed. Here I have diameter. Radius is half of the diameter. So I'm going to figure out my radius for each cookie, and then I'm going to find the area for each cookie. So pi times 12 squared gives me 144 pi for the larger cookie. For the smaller cookie, pi times 4 squared gives me 16 pi. If I want to figure out how many 8-inch cookies would be equivalent to two 24 cookies, I want to see how many times does this fit into this. So I'm going to take 144 pi and divide it by 16 pi. When I do that, the pi's cancel out, and then I just have 144 divided by 16, and that's 9. Okay, so 9 smaller cookies would be equivalent. Oh, I messed up. Ooh, no. It says how many 8-inch cookies would be equivalent to two 24-inch cookies. So I was wrong. I have to multiply this answer by 2 first. So 288 pi. So 288 pi divided by 16 pi. I'm going to cross those out, and I should get 18. 18 cookies. Sorry about that. All right, number 15. A right rectangular prism has a length, width, height, and they give us the dimensions. If length, width, height are quadrupled, this word quadrupled means times 4. What is the ratio of the volume of the new right rectangular prism to the original right rectangular prism? So this is where we're going to do our similarity stuff. We have scale factor. If I quadruple something, that means my scale factor is 1 to 4. Quadruple is 4, triple is 3, double is 2. Okay. I want to figure out the volume ratio. So when I do volume, we do the scale factor to the third power, so 1 to 64. It did not ask me to figure out the new volume, so I don't have to do anything else. It only asked me for the ratio, so I can stop there. A right circular cylinder has a radius of 4 centimeters, a height of 7. If both the radius and the height are tripled, what is the ratio of the areas? So my scale factor, when I triple something, means 1 to 3. If I do the surface area, any type of area, I square my scale factor. So it's going to be 1 to 9. Now this specifically says the new right circular cylinder to the original. So if I did new to original, I would have to switch my order around and say 9 to 1, because this was the original to the new. So I would just have to flip it around. A rectangle has a length of 6 and a width of 4. If the sides of the rectangle are doubled, what is the new area? So this one is slightly different. I'm doubling, so I know my scale factor is 1 to 2. I'm doing an area problem, so I know I'm going to have to square this to get my ratio. Now this question doesn't say stop at the ratio. This one actually wants the new area. So if I want the new area, I'm going to have to figure out the original area first. When you have a rectangle, you multiply length times width, so the area would be 24. I'm going to use my ratio 1 over 4 is equal to 24 over x. Okay, I cross multiply and I get x times 1, which is x, and then 4 times 24, which is 96. So 96 would be my new area. And what is this? Centimeters, so centimeters squared. Okay. Number 18, a right rectangular prism has a length of 4, a width of 3, and a height of 6. If the edges of the right rectangular prism are quadrupled, what will be the new larger right volume of the new larger right rectangular prism? So scale factor first is 1 to 4. My volume ratio, I have to cube my scale factor. So 1 to the third is 1, 4 to the third is 64. Again, this one we are not stopping at the ratio. They actually want the new volume. So I have to figure out the original volume first. Volume for a right rectangular prism is just length times width times height. So 4 times 3 times 6. So that should be 72, I think. So I'm going to use my ratio. 1 over 64 is 72 over x. Cross multiply, 1 times x is x, and then 64 times 72, 4,608. And this is in inches, so we would add inches cubed on the end there. Okay, number 19. The ratio of the surface areas of two similar cubes is 4 to 25. So this is our area ratio, 4 to 25. What is the ratio of the volume of the smaller cube to the larger cube? So this is what we talked about where we have to work backwards. We're starting with area and we have to work backwards to scale factor first. When we work backwards from area, remember area is something squared. So opposite of squaring is square rooting. So to work backwards, I have to take the square root. So I say the square root of 4, the square root of 25. That gives me 2 over 5. Now I can work forwards to volume. So if I know my scale factor, oops, that was a bad exponent. I have to raise those to the third power. 2 to the third is 8. 5 to the third is 125. So this would be my volume ratio. Number 20, the ratio of the volumes of two similar spheres is 27 to 125. What is the ratio of the surface area of the smaller sphere to the surface area of the larger sphere? Again, we got to think about working backwards. These are cubed. If I work backwards to scale factor first, I have to take the cubed root of 27 over the cubed root of 125. We talked about where this button is on our calculators. It's the green that is above the 0. So to get there, if I type in 27, I have to hit the green button and then 0, and it gives me the cubed root. So this is going to be 3. If I did 125, green button 0, it gives me 5. That's my scale factor. Now I can work forwards to my area. Area is your scale factor squared. So I square the top and I square the bottom. So 9 to 25. Okay,